Party barge, floating bridge, or luxury raft. Some of the many functions of pontoon boats. While a pontoon's basic design hasn't changed much over the years, new marine materials have made these crafts bigger, sleeker, sturdier, and faster. In the old days, 45-gallon steel drums kept pontoons afloat. That rudimentary technology has certainly evolved. Modern boats have custom-built floating chambers made of a special aluminium alloy. Floating chambers start off as sheets of aluminium. This rolling machine forms them into tubes. To curl the metal, the roller in the center applies pressure equivalent to the weight of 26 elephants. A worker slides each cylinder onto a track to stabilize it for welding. A pacing machine regulates the speed of the welding torch so that it joins the tube's edges evenly, producing a solid, watertight seal. This rolling machine, meanwhile, shapes aluminium sheets into tapered cylinders called nose cones. The operator manipulates hydraulic pressure and rollers to mold the aluminium into the right shape. They use a special aluminium alloy to make the chambers shockproof. Next step, turning the nose cone into a leak-proof chamber. First, the welder clamps the nose cone together to position it for welding. Then he begins to fuse the metal seams. The unique shape of this piece requires manual welding. This type of welding, called TIG welding, generates temperatures that can reach 5,000 degrees Celsius. The nose cones will sit at the bow of the boat, in front of the other floating chambers. The waffled component at the end of each chamber is called a baffle. It gives extra protection against leaks. This hydraulic press squeezes the sections together for an extra snug fit. Chambers are welded together to form floats. The number of chambers per float varies depending on the pontoon's length. These risers will hold the pontoon's floor in place. Each chamber floats on its own, so even with several punctures, the boat would stay afloat. A worker injects compressed air into each chamber to check for leaks. He coats the welds with a soapy solution which will bubble up in the case of an air leak. Workers install aluminium cross members that will easily support all the weight that has to be added on top. A worker uses a pneumatic torque wrench to bolt the cross members into the risers with rust-proof nuts. They construct the boat's floor from sheets of pressure-treated plywood. They drive these pop rivets through the wood, anchoring it securely to the cross members. Workers custom cut and glue down a marine carpet. Its fibers are plastic, so even with all that water, they won't rot. Now for some fade-resistant decals to festoon the pontoon. Rollers crimp aluminium side panels to make them stronger. Corrugated panels don't warp or wobble as much as flat ones. A worker fastens the panels onto the railing. This shaping machine curves the railing in all the right places. It bends the soft, malleable metal with progressive pressure. Workers bring the assembled pieces to the platform. A mixture of different screws and bolts secures everything onto the boat's floor, including the furniture. The pontoon's captain will control everything at the helm with this console. The switches for the horn, lights, music and breakers sit at the top of the console for easy access. Extra touches bring some of the comforts of home to this craft. Wires and control cables connect the captain's console to this 50 horsepower motor. It's by no means a high-speed engine, but it gives the pontoon all the power it needs for a leisurely spin on the lake. Hello, sailor. Coming up after the break, grandfather clocks, a manufacturing process that takes time. And fuses. We're enthusiastic about this one. See you after the break.